Hello everyone, I am Rohan Katkar. So today we are going to learn law of large numbers. So which is very important and interesting concept of mathematics. So today we are going to learn this. So this is related to probability and statistics. In this we will learn what is the meaning of law and how it is used and what are the examples of this law. And also we see some applications of this law in real life. So let's begin. So firstly, let us understand what is the law of large numbers. So firstly, the law of large numbers applies to probability and statistics, and this law defines that as sample size increases, the sample mean tends to get closer to the population mean. So you can see through this diagram, the sample size of the population is getting closer to the population mean. So it means, what does it mean? So it means whenever the sample size get closer to the average of the whole population as it grow, because of the sample because the sample is more representative of the population as it becomes larger. So you may understand this through some examples. So let us see some examples, very basic examples. So we will see, we will understand the law of large number through this coin flip example. So we know a coin have two sides. One is head and one is tail. Head T is represented by capital H and this is by capital T. So we know that once we flip the coin, so getting of head, the probability of getting head is 50%. There is a 50% chance of getting the head. It is 1 by 2. And same for our tail also. But let's see here only head. So here what is the sample size? Here sample size is 1 because we flipped only one coin. So the sample size is 1. So this is okay for only one coin. Let us assume there are many coins. There are thousands of coins. How you will how you calculate the probability of a head getting? So where this is the time where we use the law of large numbers. So let us see example. So let us assume that we have 10 coins, and when we flip the coins, the chances of getting the head is 7 and getting a tail is 3. So the probability is 70% of getting the head. So if we increase this again, sample size, here sample size is 10. So if we increase this to 100, so let us see, this is a 55 of getting head, chances 55. So it will become 55%. Again, we increase the sample size to uh, what is 500. So we increase the 500. So chance of getting head is 268. So here again it is 53.6% chance of getting the head. Let us again increase the sample size. We increase to 1000, and now the getting of head is nothing but 51.5% chances is there. So what we can understand from this example? So what we will understand from this example? So we can understand that we know that through the previous example, we can understand that whenever the sample size increases, it get closer to the theoretical value whatever we got from that. If we flip the one coin, when we flipped the one coin, it was only 50% chances of getting the head. So when we flip the 1,000 coins, that was equal to 51.2%. So they resembles to each other. So it is better to take large numbers of sample to getting the accurate value or a theoretical value. So that is the law says here. So again, let us understand through again an example, that is dice example. So you will understand very better through this example. So the accurate value you are taken here. So let us throw a dice. We know dice have one, two, three, four, five, six sides. We know all this. So now what is the probability of getting 6 when we flip a dice or we throw a dice once? That is 16.67% chances of getting the 6 on the dice. This is the chances of getting 6. Okay. So this is only sample size only 1. So we can conduct. So let us conduct the series of experiment by giving different sample sizes. Um, so okay, let us take 20 times. When we take 20 times, we throw the dice. It will give a 4 6s. Okay, when we throw the 20 times, it will give 4 out of 20. Are you understanding? And when we throw the dice 100 times, the chances of getting 6 on the top, that is 19%. That is 90 out of 100, it will become 19%. So again, we increase the sample size, that is 500 times, it will be 19 by 100. Sorry, here I mistaken. I think this must be, sorry, I just mistaken here. This is, sorry, I am mistaken. Hmm, okay, okay. So this is not 90. Here it is 90. Okay, sorry for this. This is 19 by 100 when you flip that 10 times. And here not it is not 19. So it is somewhat, I think this is 90. I think this is 90. Yeah. And here it is 500. So 90 by 500, it will be 19% again. So, and when we throw the dice 1000 times, it will become 168 by 1000. It will become 16.8%. So you can see here, as we increasing the sample size here, you can see 20 times, 100 times, 500 times, 1000 times. So it is gradually increasing. So it means what? It means the whatever probability of getting the 6 we are getting here, it will be equal to the accurate value, whatever is there. See, this is accurate value. This is theoretical value, accurate value, whatever you can say. So it is becoming equal to this P of 6. So this is what the law of large number says. So when we increase the sample size, so we get very closer value that we want, we needs that. So these were examples. I think you may understand this concept very accurately. So now let's go through next slide. So this is one graph. So through this graph, I can understand more about this. So see here, this graph shows uh, a smaller, means this is a smaller size. Whatever this curve is there now, this curve is of smaller sample size, and this curve is there. It is a larger sample size, and this is our accurate value of mean that we want. So whenever we increase the sample size, this is a larger sample size. So it will become very closer to the whatever we want here, average mean. So this is a very, uh, I think this will be understood. So let's go to the next slide. So these are some, what do you say? So friends, these are some condition for law of large numbers. So first is independence and identical distributed variable. So here in this law of large number, there it is independence and it also identical distributed variables are there in this law of large numbers. Finite mean and finite variance. Yes, it is not infinite now. So here must be large sample size. So we take here large sample size. So then only this law of large number can be uh, it can become true for this condition. So independence of observation. So every observation must be independent and random sampling. So sampling must be random. So let's go to the next topic. So let us solve some examples. I will solve only one example. You can see this. So this is first example is a fair six die is rolled repeatedly. Means when a six-sided die is rolled repeatedly. So what is the accepted average value of the outcomes as the number of roll increases? Whenever the rows increases, what is the accepted value they have set to find it? So it is very easy. When the accepted value of the rolling if here 6 die, the average number goes through 1 to 6. So which is 1 plus 2 plus 3 plus 4 plus 5 plus 6 divided by 6 plus 3.5. So this is the answer. So according to the law of large number, as the number of rows increases, the average outcomes will be approach to 3.5. That is it. So you can see other these two examples for your understanding. So let's go to the next slide. So here are some real life examples. So before going to the real life examples, I want to again repeat the what is the meaning of law of large numbers. So see here, it's very simple. It is very simple. So the law of large number is nothing but this means that the larger the sample size, closer the proportion get to the accepted value. It's that is the meaning of law of large numbers. So whenever there are the larger sample size, the closer the proportion get to the accepted value, whatever we want. For that, we must take large numbers, large number of sample size. So this is very important in statistics. So this law will very important in statistics. So let us see some real life examples. So first one is this law of large numbers is used in the insurance companies. So how it is used? So it helps to estimate the values of frequencies of future claims they will pay to holders so that they can run the stable business. So yes, they are to estimate the value of frequency in the insurance companies they use. So this will help for them. So next is in automobile companies also they use. For example, Tesla. So in Tesla, they I think they calculate the gross sales per year and they whatever it is. So you can see it is in the automobile companies also. That is a very poor example, Tesla. And we also use in the Tech Mahindra. So these are some mathematical applications of the law of large numbers. So thank you guys. Uh, Thank you so much for. Uh, I think you must. I think you have understood this law of large numbers. Thank you.